So you can see my screen, right, Ahmad?
Yes, I can. Thank you.
Yeah, thank you. Hi, everyone. Firstly, very good morning and welcome to all of you. So, as discussed yesterday, today we are going to delve into the fascinating world of natural language processing or NLP, right? So, hope you had no questions from the yesterday's class. Of course, it is a one day class. I mean, 1 hour class, and finally at the end of the class, I was telling you, right, finding the correct weights and biases is nothing but your model training. So whatever may be the model, deep learning model or generative AI model. I mean, generative AI models are also kind of deep learning models only. The core becomes deep learning itself. So finding the correct weights and biases or nothing but your the training of the model. Okay. So today we are going to start natural language processing. Okay. So hope you are all ready. So, firstly, I would like to ask any one of you what is natural language processing basically. So, okay, this proper definition might not be, everybody doesn't know this definition, but it is quite common. Let me take you through the definition of natural language processing, and we'll see first how things are. Okay, so to understand why NLP is so crucial, let's first look at the world of data. Okay, so as you can see from this chart, a staggering 80 to 90% of the world's data is unstructured. Okay, the first one I have kept over here. So this isn't the neat organized data you find in databases. Okay, so like a spreadsheet or databases. So this is not that kind of data. So this is kind of messy, complex and human generated data of emails or social media posts or Twitter posts and documents, and of course spoken text or spoken language. So those are all coming under unstructured data. Okay, and then coming to the semi structured data. Semi structured data is neither completely structured or nor unstructured. Okay, so it is more like JSON or YAML data we are having, right? So it is a little bit structured, but it doesn't, it won't be structured in such a way like rows and columns. Okay, just like we have in tables and tables and I mean rows and columns in the tables, right? And we have the third type, structured data, as you already know if you are a data engineer or someone who work with the tables. So if your data is in the form of rows and columns, then it becomes your structured data, which is of just 5 to 10%. Okay, so almost 80 to 90% of your whole data is unstructured itself, right? And yeah, on the right side you can see a person, right? So and you can see a smart speaker. So nowadays we have lots of AI devices through which we are conversing and getting some replies, right? You do this task, you play this song, something like that. Okay, so this particular device has to recognize the sound of this person, I mean whatever she says, and convert those sound waves into text, understand the intent behind the words, turn off the light, and then execute a specific action. So she will this device will be turning off the light. So it has to understand that language spoken by a person. But how is this becoming possible, right? So this seamless interaction is powered by natural language processing. Okay, so that is the beauty of natural language processing. Now, so whatever may be the data, we see a computer cannot understand it, right? So even the English language also. So let me go to the next slide, and I'll come back here. So this is the question I have: can computers understand human language? Of course not. A computer cannot understand human language at all. So if it is a text, so it will be converted, the words of the text will be converted into some numbers. Okay, and if it is images, images also same thing. Images are made up of number of pixels, right? So these pixel values represent image features. Okay, So if you want some clarity on that, I could take you to how the images and all will look like. Okay, so let me take over there. Just give me 2 minutes. So this is a convolution neural network, and see here you can see, right, a lion picture over here. It is represented with number of numerical values. These are nothing but the pixels. All right. So these pixel values, so they might be in some dark color or white color depending on that particular value. A pixel will be, and as you can see, more number of pixels, the picture is more clearer. And if you go towards the right, so we have less number of pixels. Okay, and the picture is little bit blurry, right? And the middle one is also same. As we go down, decreasing the pixels, so like your smartphones, whatever you're having, also like 5 megapixel photo will be little bit clearer, right? And when compared to the some 150 kb one, so that's the same thing. So usually I keep these kind of representations. So yeah, internally, when even for frames, or the frames I'm saying, right, internally these kind of calculations will be happening inside the frames. So we will cover this in a very easy way. That is, you need not to worry about this calculation, this padding, so these kind of things. Okay, so I'm just showing, even the frames will be like images per second, so they will be moving, right? So that's what I'm wanted to say here. Where am I here? So yes, videos is nothing but frames. That's what I'm saying. Frames are processed along with the temporal features. Frames are also need to be converted into some kind of numerical form, and audio also need to be converted into some kind of numerical form. So if you did not get the matter what I'm trying to say here, whatever may be the information you're going to send to your model, a computer based system, it can't understand that. It has to convert that into some kind of numerical form. Okay, numerical form in the sense numbers. Okay, just like I have kept over here. So text processing, when you give some kind of see, whatever she said, right, hello, so it will be converted into some kind of numerical form. And video is nothing but frames per second, right? So number of images moving per second. So the same thing, frame one, it will contain numerical values, and just like that. And images also same, just like you have seen over there. So this is a colored image. That is the reason you have three vectors, I mean 255, 128 and 0, that we'll see in depth in our classes, regular classes. Okay, so this is a color photo, but the lion photo I have shown you, that is a black and white photo. That is why you are seeing a single value. Okay, so just for clarity I'm saying, but all these things we will learn. and and what is next? So basically you can understand this, right? What is natural language processing? So let's formalize our definition. Natural language processing is a specialized field of artificial intelligence. Its primary goal is to bridge a communication gap between humans and machines. Okay, this is not machine learning, this is machine. Okay, so NLP is that particular technology which bridges the gaps between the human language and the machine. Okay, so it acts like somewhat like a mediator in between. So that's what I'm saying. So NLP stands for natural language processing. It is a field of artificial intelligence that enables computers to understand, interpret, and respond to human language, both spoken and written, right? And here also you can see it, right? Computers traditionally operate on structured numerical data, like you have seen some kind of see, we have data in a structured manner, right, in the numerical format. That's what it means, in a structured numerical data. And but human language, if you take, it is inherently unstructured, right? So sometimes we'll say, hey Naveen, how are you doing? And sometimes we'll say, hey Naveen, how are you, and how are you feeling, something like that. Even for a single sentence, we even for the single meaning, we'll change the sentences completely, right? So that's what it means, nuanced and unstructured means. And NLP provides the tools and techniques to enable computers to read, understand, and interpret even generated human language. Okay, just like what that lady was saying. Okay, so even for the conversion of from one language to the other, from English to French and all. So these are all some kind of the capability of this particular mediator. Okay. And till now I have just told you about the definition of NLP, but we did not discuss on applications of NLP, right? So now let us see them, and you will be stunned. And you can see here the applications of NLP, right? So from speech recognition, we'll start from here. You already know, right? So think of your transcription services or the voice activated systems in our cars and homes, and crucial accessibility tools for those with disabilities. Okay, so few people are handicapped, and they are having some AI kind of machines or devices with them. So with just verbally they can just command, and that particular machine is able to do that task. Okay, so that's what a speech recognition means. And sentiment analysis, I need not to say this sentiment analysis. See, for example, if we visit a movie, after we watch a movie, we'll be providing some kind of feedback, right? The movie is astounding, or the movie is excellent, but the sentiments did not work, the action scenes are over, too much hype kind of. So those kind of all, or the words or sentences are nothing but sentiments. Okay, and your machine should understand that sentiment. So if you say the movie is excellent, it should understand that the feedback is positive, and if you say the movie is bad, it should understand the feedback is negative. Okay, so you can also say, right, so the movie is average kind of, so it should also take that as average, I mean the medium. All right, so sentiment analysis is all about that. And social media monitoring, that's how some hatred posts are there, right? Immediately the machine learning or deep learning algorithm, it completes, deactivates that particular account, even it is Twitter account or Facebook account. So if you have some kind of communal violences or a hatred post going inside the websites, automatically that system will take up and deactivate that particular account. So in those cases, sentiment analysis of a model is important, and natural language processing, one of the application is being this one. And text summarization, as you know, we have lots of apps like way to SMS, and in shorts particularly. So some 100 lines of news will be converted into some 6 to 7 lines of meaningful sentences, right? So that is also capability of your NLP. And information retrieval, like Google or Perplexity AI you're using every day, so that is nothing but your information retrieval. Content generation, so the automated news writing or document writing or notes writing, whatever it is. So our NLP, one of the application here is that. And machine translate, so you might be using this Google Translate every day, I mean, to convert from one language to the other. So that is also chatbots, virtual assistants, and text classification. So these are all quite common. So these are self-explanatory, right? So these are the applications of NLP. Okay, so by this time you would have got one doubt. Okay, yesterday also I was showing some of the applications of deep learning, and some of them here are common between both of them, right? But how? Okay, so chatbots and virtual assistants, this and sentiment analysis were also part of your deep learning applications as well, right? But how we kept those applications over here? So so for that, you'll be getting some understanding in the next slide itself. Okay, so okay, sorry, so this particular slide is nothing but this information I kept in a different manner. So these are the three types of applications of NLP, and so I segregated them, each and every, for each of them. Okay, and yeah, this is where I'm telling you about. So when this evolution of natural language processing was taking up, right, it was in 1950s was a time when this classical NLP started. This NLP has started, and then we moved to deep learning NLP. Okay, so it was in 2012 to 2017. So we were using deep learning NLP. So and from 2017 we had this modern NLP with the transformers. Okay, so when I say this classical NLP, so during that 1950 to early 2010s, okay, early 2010s, people were creating some kind of AI applications using this natural language processing itself. Okay, so they might be some kind of chatbots or any models that were understanding the human language. So the people were using some rule based systems. Okay, rule based systems, if I say. So for example, during 1956, I don't remember, we had this Eliza chatbot. So just like we have chat gpt, we have Eliza chatbot. Okay, so that was the first chatbot. Okay, so it was around 1956 something. So people were using some rule based system, something like, if I ask it how are you, it will say fine, and it will come back like how are you. Okay, so people were very much impressed by that capability. So a machine is talking to us, so it is asking us again, I mean, how you are feeling, something like that. So usually we have by the time in 1950s, we would have hard coded the values. Okay, so if somebody asks you how are you should reply back as how are you. Okay, so those kind of classical NLPs were started during 1950s. And as you can see, by over the years, we see lots of advancements. And 2012 is a time when deep learning has boomed, and it has taken up the NLP. Okay, the capabilities and NLP increased a lot because this deep learning neural network, so they performed really very very well. Okay, that's what you'll see in the next classes. I mean, RNNs or LSTMs or GRUs, when I talk about them, it means that same thing, deep learning NLP. And modern NLP with the transformers is something like that chatbots you are looking at, right? The chat GPT or Claude, Perplexity AI, whatever, they are all part of your modern NLP with the transformers. Okay, so this is the time. So from 2017 it was started. Okay, when transformers, this particular deep learning neural networks came into existence. So everything has changed, and we started building chatbots immediately. Okay, so that is the point. And today we will be looking at the classical NLP, though it is not important for a generative AI engineer, but it is really important. Why? Because you need to understand how things were going on earlier, and how we have moved on, and how do we advance that particular technology is what we need to understand, right? That is the reason we will discuss about classical NLP, and then we'll slowly move forward. All right, so I know that I can't say, I can't explain all these things in a single sitting. So that I so we will cover most of it. Okay, and I have a chatbot over here. Okay, let's say, so I'm just coming down once again. So this is a chatbot. I kept a simulation for you, as I said, right? I usually keep this kind of simulations for a better understanding. Okay, so we have a chatbot here, and I asked it, what is the weather in Hyderabad today? Let's say this is what I have asked. And immediately, to answer to this particular user's question, it will be doing some kind of processing inside, right? So that processing I kept in steps. Okay, so first the text pre-processing will be happening, and then tokenization will be happening, and this text representation or feature extraction will be happening. Okay, so that is the reason text representation is being generated and feature extraction is running. So these both are quietly common. Okay, but two steps will be going on inside. And then model inference is happening, response generation is happened, so the chatbot will be able to answer our question. So these are the processings that might happen inside a chatbot to reply to the user's question. Okay, okay, hope you got this. So basically we will have to go through this the text processing first. Okay, how this text processing is going on. So that is for our main aim today. Okay, so this is classical NLP. So deep learning NLP is a little bit different, and a modern transformers NLP is also different. But classical NLP will have set of the sequence of things to do. Okay, so first whatever the text we gave, so it will be undergoing these kind of steps. Okay, so let me take you through the notepad and give you an official introduction on text pre-processing. Okay, yeah. So what is this text pre-processing? So we have seen, right, whatever the question you give. So you can read the definition over here. Text pre-processing in NLP refers to the series of transformations applied to a raw text data to convert it into clean, consistent, and structured format that downstream models can effectively ingest. And of course this definition is little bit um, little bit too much, and little bit heavy kind of. So we can say it as cleaning stage. So whatever the text you give, right? So I asked it what is the weather in Hyderabad, right? So firstly we will have to clean the text inside the model. So when it undergoes the text pre-processing, the main step it will be doing over here is cleaning that particular text. Okay, let us see how this cleaning happens. Okay, so firstly what it will do is that it will lowercase whatever the text we give. Okay, so to in order to save some time I have written things over here, but the purpose of it I'll be writing once again over here. Okay, so the first step it will be doing is lowercasing. Okay, so convert every this is self-explanatory, right? So convert every letter in our text into lowercase. Why? Because I mean, let's see the example first. This is the example we have, and after that this is how it looks, right? But we need to understand why this lower casing has to be there. Why? Because a computer sees this word and this word differently. Okay, a computer sees these two words differently because it doesn't know, it considers this is a one word, and this is a second word, but actually these two are same. Am I right? So that is the reason we will have to lowercase it. So lower casing will make both the words same, right? So that is the reason we will be lower casing. Okay, hope you got this, why we will have to lowercase it. Okay, and now punctuation removal. This is the second step. Remove all the punctuation marks like commas, periods, question marks, and exclamation points. So for example, if you have this text, it will be getting converted into this form. Okay, whatever the maybe the punctuations you have, so all these will be removed. Why why is the question again? So basically what happens is that if any model, even your basic LLMs also, they will consider comma and full stop or any quotes as a separate things. So we call them as tokens actually. So I did not introduce you to tokens, so I cannot use that particular word. Okay, so these are considered as a separate words. And also if you are using let's say excellent, let's say excellent, and you keep something like that, but for your model, as you for any kind of machine, it can't understand this particular thing, right? For this quotation, so for us it is surprising, or we are enthusiastic to say this particular word. So whatever the marks you got, you're excellent, man. So something like that we tell, right? But in those times we usually put these kind of exclamation marks, but for a model, it looks at the entire sentence and it finds whether how enthusiastic we are. Okay, that is the reason, since it is considering these two as a different words, for a machine it doesn't matter, so it will convert this to this form. Okay, so that is the purpose of punctuation removal. And then stop word removal, right? So this is the third one. What is it basically? So stop words are the most common words in a language, like the, a, is, in, on, and. So we remove them from our text. Okay, so for example, we have this, right? Before, the cat is on the mat, but after it becomes cat mat. So it has removed, what did it remove? The cat, the it removed, and is, on, the. Okay, so these things our model has removed, and it makes this particular two words. By this time you would have got a doubt, right? But this is, this sentence is giving a meaning. The cat is on the mat, but a model is able to take this cat mat, but it doesn't for takes the context, and even it doesn't gives the complete meaning, right? But the classical NLPs were performing like this only. Okay, the classical NLP, the systems that I was telling you from let's say 1950s to early 2010s even, So that the models are, if you built a chatbot, so they were doing this kind of text pre-processing inside. Okay, hope you got this why we do it. Why we do it? So if you didn't get, so why we do is that these words appear so frequently, and they don't usually add much unique meaning, right? So removing them helps our model focus on the words that are actually important. Here in this particular sentence, the cat and mat are actually important. So it's like filtering out. It's like let me keep in this manner, filtering out the background noise to hear the main conversation. Okay, so we can keep this in this simple manner. So if you are making a phone call and you have a lot of background noise, and you know that the other person, the opposite person, he needs to understand what exactly you are saying, or at least the important things, right? So we will keep the important things only, and rest of the whatever the noise getting created, we will remove that. In the same way, the model removes the stop words. This is the same thing. Okay, and then most importantly, this tokenization, right? So what is this tokenization? Tokenization you would have heard many times, right? So if you didn't, let me tell you. Okay, so tokenization is the process of splitting raw text into smaller units. So we call those smaller units as tokens, such as words or sentences. Okay, and tokenization is of two types: word tokenization and sentence tokenization. We have two types of tokenizations. Okay, so whenever you send this kind of text, your model internally, it converts into tokens, which means these words, separate words. So I was telling you, right, this particular whatever the mark, punctuation mark, it will be considering as a single a token, kind of like a word it will be treating. Okay, and then we have then called his team. So we have split this particular sentence into the words itself, and this is how it looks. Okay, so hope you got it. So why we will have to do the tokenization? So if you are already using this, let me open some Gemini, Google AI Studio or something where it shows this, right? So when you have any questions, you will be asking in ChatGPT, right? In the same way, we have something like Google AI Studio as well. Okay, here I can show you what tokens are exactly. So let me put it over here. So let me tell this thing. What is the latest technology um, in heart surgeries? Let's say this. Okay, of course this doesn't give any meaning, but let me just give this to our chat box, and let's see how our model is counting. See, you can see, right? So token count, it is taking the token count, which means whatever the number of words it is going to generate. See, it is counting, it is thinking right now. So this chatbot is thinking right now, and it provides some output to us. See, it is providing some output, right? In the same manner, the token count will be increasing, because each of the word it takes up, so it calculates that count. Okay, let us see what will be the response we'll be getting. So the response is completed, and you should see the token count over here, 1467. So if you count the number of unique tokens over here, it becomes something like 1467. Okay, at least in the classical NLP, where the each word is considered as a single token. In classical NLP, each word is considered as a single token. Okay, hope you got what tokens is. For the time being, you can consider them as a words itself, a token equal to one word. Okay, so now hope you got this tokenization. Now it is time for us to move to the next text pre-processing step, which is stemming. Okay, so what is this stemming? So stemming is nothing but, chopping off the ends of words to get to the root form. Okay, so for example, you have these studies So for example, let's say Naveen studies in the evening. So you, if you give that a particular text, the studies or studying, whatever we have in the sentence, it will be converted into some kind of root form, some kind of this root form. Okay, and connection or connected, it will be connects also, it will be converted into connect. Okay, so it is bringing all of the words to into its root form, and this particular root form is called as stem. Okay, this is one stem and this is one stem, so like that. All right, hope you got this. And but why, we need to understand why, right? Why do we have to do stemming? So basically, so we want the computer to know, let's say the same example, running, ran, runs. So all these words uh, as a common words of run. Okay, so what I'm trying to say is we want the computer to know that running, ran and runs are all related to the core concept of run. Okay, so these are all belonging to the run itself, right? So when you give this kind of sentence like let's say Naveen is running in the park. So whenever we give this particular sentence to a chatbot, it converts these kind of text. One second please. Yeah, so these kind of words into its root form. So run gives you run gives the model what verb it is, actually what action is going on. So we will have to convert this kind of words into its root form. Okay, so that is nothing but your stemming. All right, so now the last one of text pre-processing, at least limited to the classical NLP, is your lemmatization. Okay, so what is this lemmatization again? Lemmatization, it also reduces words to their root form, but it uses a dictionary to make sure that root form is a real meaningful word. Okay, so let's say you have this kind of word in your sentence, better is there. Okay, so your model converts this particular better to something like good. Okay, because these two are connected with each other, I mean these two are related to each other, right? So if you have a better and good in your sentences, so it will be converting it to its root form as good itself. This better gets converted into good, and this good becomes remains as good. So this is the first example. And before this is another one, was, if we have was in your sentence, it will be converted into be. Okay, so it knows was is a past tense form of the verb to be. And also in the same way, studies, studying, this is important actually to understand what is the difference between stemming and lemmatization. So if you have the same studies and studying, so in stemming it becomes study, which doesn't have any meaning, which doesn't have any meaning. But but here it converts into study, which means it has a good meaning. So notice the result is a real word. Okay, unlike with stemming it creates one word which doesn't have any meaning. However, if you take up this lemmatization, it provides a very good word at the end. Okay, so we have completed this text pre-processing. I would like to say this: are we going to do all this manually? So that is one thing. So you just have to write a simple code. Okay, so just like I thought of showing you that it is very simple thing. So you'll just have to import some NLTK libraries, NLP libraries like NLTK, Spassy or Gensim. So we have three different types of libraries, and you just write a single line of code. Okay, which I'll be explaining in our regular classes, of course. But all these steps, what I meant to say is that all these steps you need not to do manually. You just have to write a single line of code, okay, which is very easy. That also, if for example you have this thing sentence, you just write it as lower of your text. Okay, so when you do like this, it will be lower casing your letters, the words completely. So this is a simple code, right? lower of text. In Python is nothing but a very easy language, and which is very much common to your English language, so it is very easy to write the code as well. So this is how we'll write. All right, so we have completed this text pre-processing. Right now what will happen, so once the text pre-processing is over, what is the next step we have in that chatbot simulation? We have vectorization or feature extraction, right? So please ignore this spelling mistake. Okay, so once this is, text processing is done, the next step is vectorization. What do you mean by vectorization? Vectorization is nothing but the one I have been telling you from the beginning of the class: converting your words to words to numerical form. Yeah, numbers, correct. Some kind of numerical form. All right, so this is nothing but your vectorization. And of course, for classical NLP you have different types of vectorizations, like a bag of words or TF-IDF. And for your deep learning NLP you have different types of vectorizations, like word embeddings, where we'll be using glow and word to vec, or gensim as well sometimes. And your transformers, you have some types of vectorization, like byte pair encoding and all. So all these things we'll see. But for you, I'm just giving you a simple a meaning of what is vectorization. Vectorization is nothing but creating some kind of numerical vectors, like you have seen, right? Images and all, they gets converted into vectors, something like that. All right, so this is the next step of whatever you are going to learn in NLP. So this is how we follow. Okay, so hope you got this. And it is time, if there is someone who has joined just today, I would like to uh, spend this 10 more minutes on the brochure, or I mean on the course itself. Okay, so that's how we'll go. I mean, so this is how I write in the class. I mean, I keep things ready up front, like before the class. I'll show that to you, like. So for example, let's open anything. Let's open this itself. So these are my classes, the previous classes. So I have this in a recent files. So this I have taken some days ago. So this was the class, which was the class 5, and this is how I keep things ready, and I write things in a manner so that people can understand very easily. So I keep this kind of diagrams how things will go. Okay, so what happens at the last? I mean, whether the training is complete or not. And this is a neural network training. We will learn all these things very slowly, okay, in a slow manner. So this is how I write every day. So this was in some class 5 of deep learning, I guess. So like that, the same notepad I'm going to use. All right, and I was telling you, right? So this 10 minutes I'll be telling you once again on whatever we discussed. I see a new person is in the team now, and I would like to explain the things once again. So this is our roadmap. I kept this as simple as possible, actually. And even the brochure, we will cover all of the things, at least as part of this generative AI and all. We will cover in depth manner. Okay, and that is one thing. And I keep slides something like this. Okay, so sometimes our imagination, it might not be enough to capture the content in that particular concept. Okay, so in those kind of things we will have to, we can't imagine that simply. So if I keep these kind of simulations, you can easily understand that particular concept. That is the reason I keep these things. I spent a lot of time, like some 5 to 6 months on this, creating this itself. Okay, so I keep this kind of simulations to make concepts little bit easier for the students. Okay, so I mean audience, right? And that is one thing, and we'll be providing the study material as well, as I was telling you, and I have shown you the study material also. So if some of you did not attend my first demo or second demo, kindly go through that. I mean, it is in already in the YouTube. Okay, so our team will be sending those demo videos to you, and you can go through, where I have shown you this study material, and all these things I have explained. But for now, let's keep this as simple as possible. So this is the sequence we are going to follow: Python, math and statistic for AI, and machine learning essentials. So these are the first three modules, and the generative AI will be around again some 7 modules actually, but I have kept very simply over here. Okay, so some 3 modules of your basic foundations, and 7 modules are for your generative AI. Okay, and these basic foundations will be covered by one more trainer. So foundations they are. So he will be he's Vasant Banu. He's currently working as a AI product manager in Gartner. So that person will be covering your foundations, and the main parts we have, right, the generative AI completely from deep learning itself. I'll be taking up, and till the end we'll spend some good amount of time. All right. So this is a program, and you can go through the brochure and all. Yes, of course, we have a question that practical implementation also there for each topic. Yes, we are giving actually more importance to the practicals instead of theory. So some of the concepts, deep learning and all, it requires a lot of first understanding on the concept. Okay, because deep learning is like a backbone to your large language models. So there we'll spend some 50%, 50% time on practicals and theoretical, but natural language processing and all, there we will thoroughly have a practical sessions only instead of theory. So the reason why I kept these slides is to make your theory as short as possible. Okay, so if I show this this diagram to you, I need not to explain that thing for like 20 minutes if I am explaining verbally. So if I show this within 2 minutes, you can understand it. Okay, that is the reason. That's how we are going to save time actually. Okay, so the 65 hours or 75 hours we are going to take. So it is more or less equal to some 90 or 100 hours in normally. Okay, so if I um, so let's say I'm taking up some 70 hours, it will be more or less equal to 100 hours, because we are I told you, right, we are making the concepts very much easier. So I need not to tell some examples to imagine. Okay, so I can show that directly. I have simulations ready, which gives you a very good understanding, right? So that's what I want to say. And we have one more question, I guess. So how many weeks it will take to come to deep learning? So it depends actually, because in the recent interviews that people are asking, they are asking very good questions on Python firstly, and they are asking some good questions on maths, statistics, basically statistics, and machine learning essentials as well. Okay, we will have to keep this also as important as we have this generative AI. Okay, because people, mostly the generative AI engineers are like they might be having some good knowledge on data science and machine learning already. So for them, these concepts they already know. But we said, right, some no prior knowledge is required, and we will go from basic level to this 100 level of training, right? So which means you need to have a thorough understanding on Python, math and statistics. Okay, so these kind of things. So we are giving some good amount of time for this as well. Okay, so we are adding this machine learning some topics. Okay, I mean, at the end of this classes, at least maths and statistics, we will be asking you whether we need to cover a lot of topics in machine learning, or you need only some topics, something like that. So if you are, I mean, if you take up a decision like we just need a basics of machine learning, that is fine. We will be covering only basics of machine learning. But we want it. We want to cover, very good concepts on machine learning from our side. Okay, so we don't want to miss any kind of interview question. So that is the reason we are going in an in-depth manner for this as well. I mean, this won't be like a generative AI. We will be spending some limited amount of hours only here. Let's say some 6 to 7 hours or 6 hours of machine learning. I mean, 6 classes. It will be some 5 to 6 classes. Okay, so some 5 to 6 classes or 4 to 5 classes. So you'll be having on machine learning. All right, but generative AI and all, I have shown you the videos, right? So that's how. No, no, no. Python. It will be Python. It will be like some 13 to 14 hours. Yeah, for sure you'll be having some 14 hours, because people who have approached us, they said they want in-depth coverage on Python. So we are covering more practical things and all in the Python. So it will be some 14 hours, and maths and statistics, it depends, right? So some 3 hours or 3 hours or 3 to 4 hours for this. Okay, and we'll be coming to machine learning essentials, and finally we'll be going through this generative AI. Okay, so that's the plan actually. And if you do not want that much coverage, that is fine for us. We'll provide the recordings to you. Okay, so if all of you have a good knowledge on Python, we'll simply provide the recordings to you. You can follow that. If not, you want the live class, and you have a very doubts and all, you can attend the live classes. Okay, that is better actually, as we are already covering this Python from the basic zero level. It is always better to attend the classes instead of taking the recording videos. Okay, so we stick to that. I mean, entirely live training. Okay, so that's the thing. So yeah, zero to advanced learning, as I'm saying, right? So no prior knowledge is required. Okay, and as I was saying, 3 months of in-depth training you'll be having. So that is also covered, and study materials I have shown you in the last class. I can show you today as well. Let me find it somewhere. Deep learning notes, right? Yeah, so this is how your deep learning notes looks like. I have written this from okay, so you will have everything. I mean, whatever is required for deep learning, I have kept everything. But almost you will have a very good content in your live classes than the notes I have given. This is just a gist of deep learning only. So this is like a revision kind of. Okay, but most of the matter you'll have in our live classes itself. So this is a study material we'll be providing for each and every topic, and interview questions will provide you at the end. Okay, we'll have some sessions on that as well. And sorry. Okay, so we'll provide the assignments and exercises, and you would have seen, right? So some kind of mind maps and concept simulations we have kept for almost all of the topics. I have spent some good amount of time on this actually. So even even the large language models, if you take, I was showing you yesterday, right? So some kind of these things. So you can see the architecture, how it goes, and how do we have to build the GenAI architecture like that. So so this might be confusing for you. That is the reason I did not show it to you. But we made a couple of things simple. So that is a thing. So someone is asking a question. So he's from Java background, and is that useful? Yes, obviously to learn. Say, Java is little bit more complex than Python, actually. So even the syntax, if you take here, you will be writing some 6 to 7 lines, but you'll have to write the same here as 2 to 3 lines itself. So Python is more like your English language only, but you'll have some kind of keywords, functions, and those type of things. But Python is very much easier than Java. So for learning this Python for a Java person, it will be very very easy. That is the first point I would like to say. And now you can see some generative AI postings in future on Java as well. Okay, now completely it is on Python. That is the reason we are concentrating more and more on Python itself. But in future, in the coming 2 to 3 months, so in on Java also it will start. And of course it is started for data engineers, I guess. I don't know, I don't I have seen some posting somewhere. Okay, but it is not full-fledged. You are not able to find a good amount of jobs for now, but in future you'll surely find it. So this domain knowledge, whatever you're having from here to here, even though you can even if you replace this Python with Java, this knowledge remains the same, right? So it is important for you to get this knowledge even you are a Java person, in both the ways. Okay, so that's what I'm trying to say. Yeah, do we have any further questions? uh, yeah, uh, I don't see any questions. So, and we have 5 minutes left, right? And I would like to say this again. So if you have any questions, you can ask me now itself. Um, so the batch timings here being 7:30 a.m. to 8:30 a.m. Monday to Friday, and the batch starts from the Monday. And I request every one of you to enroll to this batch today, if possible, as soon as possible. I could keep it as soon as possible, and you can check with our management. They would have provided you the payment links and all. Oh, sorry. Yeah, they would have provided you the payment links and all. So kindly enroll to this batch as soon as possible, possibly today itself. And the joining link and all, the whatever the meeting link we have shared you, that will be changing from Monday. Okay, so only to the enrolled students, so they will be providing the these links, the new link. Okay. Yes, yes, I can hear you, but it is your voice is very light. Is someone asking us any kind of question? Do you have any questions? Because I hear some voice, but I'm not able to get it. As I was, so there is one more question. So he who is teaching Python? I told you, right? Whatever the no, I don't get from where the voice is coming up.
నిద్ర వస్తున్నది నువ్వు అన్నాడంటే
Y- Yes, yes, we have them, but
ఆల్రెడీ అగో ఆ కాళ్ళకు అదన్నీ ఇదిగో ఇదిగో ఇది ఆల్రెడీ గొద్దు నల్లగా ఇక్కడ చూడు బుజ్ 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 పోసినాయి
uh, yes. Uh-huh. Yes. 1 second, please. 1 second. I hear some voice. 1 second, please. Let me correct that from my side once.